Today we will be doing a polar graph investigation, and you'll start with the lesson and learn some calculator tricks, and then you'll be practicing quite a bit with plotting different special graphs on the polar plane. So to begin, you might need to pull out your unit circle because that is relevant in today's lesson. We are going to plot all of the coordinates essentially for this particular equation to cosine theta. And on our polar plane, you'll notice that we have some extra tick marks that we don't usually use in the unit circle. Those are all the over 12s. This would be like pi over 12. This one would be 5 pi over 12. But we typically don't plot those. You would not be expected to plot those on your test. Now, what you will be expected to plot is all the unit circle values, like pi over 6, pi over 4, pi over 3, pi over 2, skipping this one over to 2 pi over 3, 3 pi over 4, 5 pi over 6, skipping this one, and then pi, so on and so forth until we get all the way over to pi. So I'm going to cross out these pi over 12s because that's not required for your test. So then when we evaluate on the unit circle, 2 times cosine of 0. Well, cosine at 0 is 1, so 2 times 1 is equal to 2. And then we plot this point. This is the theta value, and this is the radius value. So along this 0 line right here, we're going to plot a radius of 2, and so we would count forward from the center. And there is an angle of 0 and a radius of 2. Then going up to pi over 6, cosine at pi over 6 is square root 3 over 2. So we have 2 times square root 3 over 2, which ends up just being the square root of 3. And then we would need to approximate if we wanted to graph this. So if I approximated the square root of 3, in this particular case, it's about 1.7. So we'll say approximately 1.7. So I would go up to this pi over 6 mark and count forward 1.7-ish right there. Same thing for pi over 4. We have 2 times square root 2 over 2, which ends up just being the square root of 2. And then we would need a decimal approximation for the square root of 2, which is about 1.4. And then we would go up to this spot right here, that's our angle, and then we would count forward 1.4-ish, looks like it'd be right about there. And then we'll continue this process. So cosine of pi over 3 is 1/2. When I multiply those two things together, I get 1, and so I go up to pi over 3, count forward 1. And then at pi over 2, that's the top of our y-axis. We have 2 times 0, which is just 0. So going up here, we wouldn't count forward anything at all. We're just right there at the pole, kind of the origin from what we're used to. Then over to 2 pi over 3, we would have 2 multiplied by negative 1/2, and that would give us negative 1. So I would go over to 2 pi over 3, and instead of counting forward, we're actually going to count backward 1, and we'll plot that point right here. Over at 3 pi over 4, we have 2 multiplied by negative square root 2 over 2, so that gives me negative root 2, which is about negative 1.4. So I'd go all the way over to 3 pi over 4, and then I'd count backwards 1.4-ish. And then 5 pi over 6, 2 multiplied by negative square root 3 over 2. We'd get negative square root 3, which is approximately negative 1.7. So go all the way over to 5 pi over 6, count back 1.7-ish. Looks like it'd be right about here. And then last but not least, at pi, we'd have 2 multiplied by negative 1, which gives us negative 2. So we'd go all the way over to pi, and then from the center, we'd count back 2, and look, we're right where we started. So we're going to connect those dots, and this special polar graph creates a circle. Sometimes if you do not end up back where you started, you're going to have to continue and do the full unit circle. But for today, we were able to stop on this particular example. Next, I'm going to show you some calculator functions that you'll need in order to be able to graph these particular things. And as I'm going through this, I'm saying, oops, your steps are a little bit out of order, so I'm going to go ahead and change this to be step 3. But your step 1 is just to make sure you're in radian and polar mode for this worksheet. And then you will want to go to your window. In your window, you're going to adjust your calculator screen to match what it says here. And these decimals are just really negative pi, 2 pi, and positive 2 pi. And then the step is going to be pi over 12, because that's how the tick marks are all separated on your graph. And then I just picked -7 to 7 because that's what matches your worksheet as well. And then your third step is you're going to go to that y equals button in your calculator. So if I go there, y equals, I've already got it typed in, but if I were to clear this out, I would just type in 2 cosine, and then the X button, because I'm in polar mode, is now going to show us the theta value that we need for radian mode. Excuse me. Then we're going to hit zoom square, and zoom square is going to be number 5, z square, and that's because it will show us a nice window, and hey, that looks just like the graph that we made. It is the equation of a circle on the polar plane. Now, this last little part is really just to help you with graphing on today's worksheet to make things go faster. For test purposes, if we ever ask you to fill out a table, we're going to want that table to look pretty much like what we did back here, where we were giving exact values and then plotting them using those approximations. But for today's worksheet, you will definitely want to know this trick. So you're going to go to second window on the calculator, and that's going to be located right here. You hit the second button and then click this guy right here. It's going to take you to this screen. Once you're on this screen, you're going to fill in, make sure your table start is at 0, and then this delta table, the change in your table, you want that step to be pi over 12. And that's because I mentioned before, these are all incremented in over 12. So from 12 to pi over 6 to pi over 4 to pi over 3 to 5 pi over 12, all of those little tick marks on the polar plane are all your over 12s. So I have done that as well. Here's the graph that we just made. And if I go to second window, you're seeing that this is the decimal. It should auto update to after you type in pi over 12. Then we're going to go to second graph, and we're going to look at the table. And that table is pretty much identical to what we had a couple screens before. We had 0 as our input, and our radius was 2. We weren't seeing a 1.9 of a radius though, and that's because we skipped this over 12 value. If I didn't skip the over 12 value, then I would have had to plot that point 1.9. That's perfectly fine if you'd like to do that today. 1.7 matches up with pi over 6. 1.4 matches up with pi over 4. 1 matches up with pi over 3. We did not have this 0.5 value because that's the 5 pi over 12 that we skipped. And then we go over to 0, that was at pi over 2. And so you just skip and then count the next 3, skip, and then we're back to pi. And you're seeing that there, 3.14 is all the way over to pi. So you can use this feature to help you out on your investigation today. In fact, go ahead and try out graphing the next one on your note sheet. So just hit pause for right now and try to graph that next one. And then once you're ready to see the answer, hit play. And here it is. Again, we started this one at 0. And once I got back to 0, I knew I was finished with my picture. I confirmed it on the calculator. I can look at this 2 sine of theta. I would hit zoom square again, number 5. And I'm seeing that circular picture pop up. And these are the approximations that you should have had for the graph as well.